It's really a pleasure and also an honor to be here today. And I am so thankful to the organizers for asking me to do this opening lecture for the Life Science Career Day. I think those symposiums are absolutely essential for you, for your career. So that's why I'm so excited to be here in front of you today. And it was also very unusual for me because I'm not going to talk too much about science, which is what I usually do when I give talks. Today, one of my goals is to show you a brief overview of my experience doing basic research in academia and doing applied science in industry. And the second goal of this presentation, I'm going to explain in the next slide. This is a really boring slide, I know, and don't worry, it's not going to take a lot of time. This is just a part of my resume with my professional experience. And I just want to go very quickly through it, run you through that, the way I would do if I would interview for a job. So Karina already mentioned my education. I went to the US to do my PhD, which was a bit unusual at the time, working on telomeres and their involvement in cancer and aging. After that, I went back to France where I did a postdoc. I switched model organism. I worked on budding yeast, on DNA replication and genome stability. Then I decided to do a second postdoc to go back to my first love, telomeres in human cells, but with a different aspect. I decided to study their organization within the spatial volume of the nucleus, so telomeres and aging, but with this little connection with genome organization. After that, I applied to a group leader position at CNRS, applied for some grants to start my own group, which I did, and I continue working on telomeres and nuclear organization for several years. And then I had this incredible opportunity to join industry, LVMH Recherche, I will explain a little bit later, as the Life Science Innovation Manager, working in human skin aging. So this is nice. You feel, wow, what a linear career. Everything is so smooth, so easy, no problem whatsoever. But that's exactly what you would do when you go on a first date with someone. You're never going to tell your boyfriend or future boyfriend or girlfriend, or I hate doing the dishes, or I'm really messy. You're not going to do that. So you show the best of yourself. So it's the same with the career. But in fact, I had at every step of the way transitions that were difficult. I had to make choices. I had to make compromises. And this is really what I want to tell you about today, not so much about what I did, but how I went through these transitions. And the question that you can ask yourself to because you're going to experience those as well. And I hope this can help you in the future work on some of your own transition. But just for a bit of fun, I thought, okay, I'm going to talk about transition, but what is a transition? So what do we do these days? We ask ChatGPT. So I asked ChatGPT, could you give me the definition of transition in one sentence? I was very disappointed. Refers to the process of a period of change from one state to condition to another. Not very helpful. So I was more precise in my question, which is what you should do with ChatGPT. What is a career transition? And then that was quite interesting, actually. I was quite impressed. So you have to, your changing can be driven by various factors. So I just highlighted a few: personal interests, better work-life balance, acquiring new skills, or education, and so on and so forth. And you will see that I had some of those in my own transitions, and I will highlight them as we go on. Okay, so my first transition was to do or not to do a PhD. And after my master's degree, I did not want to do a PhD. I think I had the capacity, I had what you need to do a PhD, but I didn't want to because I came from a very small university, not like you. And to be honest, the PhD students in that university, they seemed miserable. And that was not attractive to me at all. I thought, no, I want to work. So I started working before my PhD, skin photoprotection, I tried already the industry, and then academia, working on drug resistance of cancer cells. And it's only then that, after those experiences, that I decided for myself that, first of all, why not do a PhD only if I like the scientific environment? And this is what ChatGPT would call reevaluation of personal goals. And I really want to experience something abroad. ChatGPT adapting to new work environment and cultures. And I really like chromatin. This is my scientific interest. So that's why I decided to move to La Jolla in California to do a PhD. So the take-home message, sometimes we need experience to drive and shape our choices. I didn't want to do a PhD before working a little bit in different settings. And then, after that experience, I knew I wanted to do a PhD, and I think that's better. So I joined the Salk Institute. I did my PhD supervised by Jan Carstetter, working on telomeres. And just a little aparté, as we say in French, about this building, because it's absolutely remarkable. It was built by a famous American architect, Louis Kahn. And you all wonder, why is he talking to us about architecture and not about science or transitions? But in fact, this is something that is important to me, the connection between art and science. I think there is a really strong connection, just for instance, for the creativity that you need in both jobs. And working in such an environment with such a magnificent building, we even had Shihuli, who's an artist creating glass sculptures, exposing in that building. It just gives you the best environment to be creative and work, to just inspire you. So it's just a little aparté, and I think that means a lot to me, because I think it's also one of the reasons why I joined the industry, and I will come to that later. So just a little bit of science. During my PhD, I worked on telomeres. You might have heard of telomeres. They are involved in aging and cancer. They shorten as cell age. And during my PhD, I showed that I worked on a premature aging syndrome, a rare syndrome where people age very, very prematurely. And I could show that there was a defect in telomere replication in cells from this premature aging syndrome that led to telomere loss, faster shortening of telomeres, which explained why those cells age prematurely. And then after the PhD, what should I do? Second transition. That transition was not so hard. I wanted to do a postdoc. That was kind of easy enough. I also knew that I loved chromatin, but I wanted to learn something new, so acquire new skills. So that's why I decided to move to a different model organism, work on budding yeast. But for personal reason, I had to move back to France, and I really didn't want to work in France. I wanted to stay in the US, but I had to go back. And this is something very important that I wanted also to tell you. Sometimes we need to adapt our choices, but adapt choices does not mean that you make bad choices. And it was the case for me, because I had to adapt. I had to go back to France, where I wanted to stay in the US. But in the end, I ended up doing an amazing postdoc with an amazing lab, Philippe Passero, and I was really successful. So in the end, it all turned out fine, because choices is what you make of them. Even if you don't do exactly what you were planning on doing, just do your best, do everything you can to make it a good choice. And then after that, I had publication. It was the best time for me to apply for a permanent position. But I was not ready. I needed more time, which Chat would say it's professional growth. I also wanted to test another idea that I had, combining my experience that I had as a PhD student and as a postdoc. And also, I really wanted to go back to California. So I made compromises, moving back to France, but I wanted to go back to California, and that's a personal life. So that's why I did this second postdoc. And the take-home message is sometimes what seems logical to everyone around us, because everyone was telling me, apply for a permanent position now, but I didn't want to. So sometimes it's not for us, it's not our choice. And I took a risk to fail, going back to a second postdoc, But I think sometimes it's okay to take a risk to fail if you really pursue what you know you want to do. It's very important. So I did a second postdoc to test the idea back in the US. I think you guessed that. I worked on telomeres again in human cells, and I combined the experience that I obtained working in budding yeast, realizing that the genome positioning within the nuclear space is extremely important for chromatin regulation. And so I kind of combined those two ideas to work on telomere and nuclear organization. And what I found is that telomeres, those little foci you see in green, in red you have the nuclear envelope that wraps chromatin. They are actually organized in a very peculiar way during post-mitotic nuclear reassembly. They are overlapping with the nuclear envelope. So the end of the chromosomes, they are anchored to the nuclear envelope. And that was the first time that people showed that. And it has implication that I might just tell you a little bit later. So then, after that, I was ready to start my own lab. So reevaluation of personal goals again. But I had to move back to France for family reasons again. But it was not the right timing. To apply for permanent position, usually you apply once a year, and that was not the best time. So I really had to combine this. I'm not going to go into details. If people are interested, they can ask me questions afterwards. But that was really a difficult period. I had a 6-month-old baby, and I worked basically 2 jobs while going through the interviews. But it all went fine. But I just wanted to say sometimes it's difficult to accommodate 2 careers and a family, but it's possible, so never give up. Even if it's hard, just go ahead, do your best, and it will pay in the end. So as a group leader, I was super interested in how chromatin is organized in the nuclear space. And in fact, chromatin can be anchored to this nuclear envelope that wraps the nucleus. And this impacts transcription, DNA repair, genome stability. And in fact, the fact that telomeres, the end of the chromosomes, can also be anchored at the nuclear envelope was quite new. And that suggested that they could also be a part of this nuclear organization. So in my lab, I don't have time to explain a lot, but I was just giving you just a few things of what we were doing. First, we were trying to understand how telomeres were tethered to this nuclear envelope during post-mitotic nuclear assembly, the molecular mechanisms, doing biochemistry. We also found out that telomeres have a very peculiar structure in mitosis, so we were also very much interested in that. We are also analyzing how the daughter cells rebuilt their nuclei after cell division. And we were trying to assess whether tethering of telomeres to the nuclear envelope during nuclear reformation could reposition chromosomes in the nuclear space. And finally, we did a lot of technique development. We did genome editing to visualize telomeres in live cells with CRISPR-Cas9. We also set up this new technique called MAD-ID to probe protein-chromatin interaction. And it was quite successful. We had really nice funding, lots of collaboration using many different approaches. It was just a lot of fun. But I had this opportunity, a call to join industry. So this slide is just to give you a little bit of what runs through my mind when I had to make the choice and decide what should I do. So my take from this was that in academia, I had the freedom, if you get funding, to explore. So freedom for exploratory research. You can make groundbreaking discoveries as well, which is quite nice and fun, a lot of fun. You have a collegial atmosphere. When you work for several years in a field, every time you go to meetings, you meet the same people. You really have this really great atmosphere that I love. The endpoints are really nice knowledge. As Nico was saying, just working just to gain knowledge. I think nowadays it's so rare to work, to have a job where the end point is just to bring knowledge to the world. And I think this is just incredible, and we should really be thankful for that. But also, we need to be realistic, we need to get grants, and we also need to get publication. Something extremely important, and I think this is something you need to ask yourself if you try to decide between academia and industry. In academia, you can work on never-ending projects. You can work for your entire life on something. It never ends. You always have something else to show, to prove, to demonstrate, to learn. And the final thing that I highlighted was recognition by peers. Once you start getting to know your community, people know your work, and that can be very, very nice as well. In industry, it's very different, but there are some connections, of course. You do applied science, applied research. It's business-oriented, which is not necessarily a bad thing. You can have immediate commercial applications. You work on structured projects with timeline and deliveries. And I know for some of you, this is going to be nice, because working on never-ending projects, that can be so overwhelming. When you start your PhD, you're like, oh my God, where is the end? I remember when I was a PhD student, my lab was next to the autoclave, and the autoclave was malfunctioning quite often, and the guy would come to repair the autoclave. He would come in the morning, the autoclave was not working. At the end of the day, the autoclave was working, and I was like, oh, he's so lucky. He has such a great job. Because you can work for 3 years and not really knowing what you ended up with. You know what I mean? So everyone knows. So in industry, it's more structured. So if you like that, that may be the way to go. It's fast-paced. It doesn't mean that in academia you just take your time and no. But in industry, it's a little bit more than that. And personally, what I really wanted, and that's the reason why I joined the industry, was diverse interactions. Yes, in academia, you can collaborate with physicists, mathematicians, and any kind of science, basically. But everyone has a little bit the same format, the same way of thinking. In industry, you can interact with people doing marketing, communication. Really, they have skills that I didn't know people would have, and that's very rich. It's very difficult, it's challenging, but it's very rich. And the final thing which matters to me is the connection, as I said at the beginning, with the Zorc, the building that I love so much, is the connection between science, art, beauty, and creativity. And that's also one of the reasons why I joined LVMH Recherche. Our mission is to develop unique and exceptional tailor-made products to serve the business of our houses. What do we mean by houses? That's how they call it in French, nos maisons. So we do the research for perfumes and cosmetics of brands like Dior, you might know Dior, Guerlain, Givenchy, Kenzo, and other brands. Yes, it's cosmetics. It sounds futile, yes, futile. But it doesn't mean it's not interesting, and I hope I can convince you of that. So by relying on creativity, innovation, in-depth knowledge of international markets and the preferences of our consumers. The building is an hour south of Paris in the Cosmetic Valley in France. It's a really nice building. It's called Helios. And we have many different areas of expertise. It's more than 600 people working in this building, doing all the R&D for the cosmetics and perfumes. So you have, of course, biology, which I belong, the department I belong, and I will tell you more in a second. You also have materials, physical chemistry, botany. We work a lot with plant extracts that are very active. Also physics and data digital. In the biology department, you have two groups, two items. What we call open innovation, and it's the department I belong, where we design and lead research projects. It's exactly like you would do as a PI, but it's related to skin. So anything related to skin. So we work on any field in biology, basically, because skin can be, you can have everything studied in the skin. Either in-house with the in vitro efficacy laboratory, where they have all the platform to do cellular, molecular biology, biochemistry, imaging, and so on, or with partners. So we partner with industry and with academic labs everywhere internationally. And what I really like is that we have this interface with active ingredients, formulation teams, claims, marketing. So that's why I was telling you, you have a lot of interactions with people with many, many, many different skills. So I know you know exactly how a lab works, so I'm not going to describe what kind of experiment we can perform at LVMH Recherche, because it's exactly like in any other lab. But I wanted to just highlight the models we work with, because doing cosmetics, we cannot work on animal models. So that's absolutely forbidden for us. Nothing on animals. Even toxicology experiments are not made on animals. So we work only with human cells and models from skin. So we have beautiful 2D models, such as keratinocytes from the epidermis. We can even isolate keratinocytes from wrinkles. I didn't know that before joining. I think it's quite funny. You can work with fibroblasts, which are the main cells from the dermis. So you have the epidermis, the top layer of the skin, and the dermis is underneath. And melanocytes, which are also in the epidermis. Those are the cells that synthesize melanin pigments that protects you from the sun. And you can also do fun experiment with co-culture when you can mix keratinocytes, melanocytes, because within the skin they are together. And you can look at how melanocytes can transfer the melanosome containing melanin pigments to keratinocytes. And that's quite fun. But most importantly, which something that I love, and I wouldn't be able to do that in my lab in academia, are the 3D skin models, because you can do full reconstructed skin, and we collaborate a lot with Lab Skin Creation, where we do bioprinted skin. And I don't know if you guys knew that it's possible to bioprint skin. And it's really amazing. It looks almost like a normal skin, and that's so powerful. It's such a great model to work. We can also work with ex vivo explants, so it's pieces of skin that we can maintain in culture for like 7-10 days, and we can do all sorts of experiments on those. And then you can, if you don't need the full skin, you can work on just the dermis, or you can work just on the epidermis, doing reconstruction of just those 2 layers. So now I just wanted to show you a little bit how it works, the kind of projects I could work or my colleagues could work on. So of course, we work to make products. So for example, Dior Prestige, which is a very luxurious brand, Nectar Premier, you think, wow, there is no science behind that. It's just a nice product, a nice packaging. It costs a fortune because it's just Dior. You just pay for the brand. But it's like when you buy a new car and you buy a Porsche or a Peugeot, you're not going to only pay the brand, right? You also pay for the quality of what you get. And it's exactly the same for cosmetics. Don't be fooled by just the names. So in fact, in this product, I had the chance to work on that. The scientific concept behind this product is the senescence. So I'm sure you all know about senescent cells. Those are those cells. They completely switch their metabolism, and they stay in the tissue. They're supposed to be cleared by the immune system, but with age, those senescent cells, they accumulate in the skin. And the problem is they perturb the skin because they express those deleterious molecules, the SASP, containing cytokines, for example, that are going to degrade the extracellular matrix and also impact the cells around themselves. And so we had this beautiful work, a PhD work with the Sorbonne University as a collaboration on this, showing that glyoxal, which is a molecule that is present in the cells, we have detoxification pathways, but we do have that in the cells. And also it's present in clothes, in some of the food, drinks. So that's a molecule that your skin can be subjected to. And to go further, after this PhD work, we decided to work with Lab Skin Creation to do reconstructed skin using bioimpression. And I'm going to show you
Chez
this
Lab Skin
video.
Création, nous avons mis au point une nouvelle méthode pour fabriquer de la peau par bioimpression 3D. Avec cette technique, on est capable de recréer de la peau en 3 dimensions avec toutes ses couches pour être au plus près de la peau naturelle et donc de la réalité. En cosmétologie, les modèles 3D permettent de mieux comprendre les mécanismes de la peau. Ils permettent aussi d'évaluer l'efficacité des produits.
Voilà. So it's quite amazing, right? They can now bioprint, if you're interested, you can look online, they can bioprint directly on people to when they are burned, for example, they can put some skin on people, so it's quite nice. So what did we do with this bioprinted model? On the left, you have just the morphology of the skin. You can see the dermis and the epidermis in the control. When you treat them with glyoxal, this molecule I was telling you about, you can just by eye, even without being a skin specialist, you can see the dermis is not as dense, the epidermis is very thin. And what's amazing is if we add plant extracts that we also work on at LVMH Recherche, we have a phytochemistry department that do that, and then we can protect those skin from the glyoxal treatment. And we also observed that P21, which is a marker of senescence, was also activated with the drug, and we could diminish this expression with the plant extract. On the right, I'm sorry it's a little bit small, but we can use those skins to do immunofluorescence, immunostaining. On the top three lines, you have markers of the epidermis. So you have filaggrin, transglutaminase, which are proteins involved in the barrier formation. So the barrier is what's going to protect your skin from the outside aggressions. And you can tell in the control or in the glycol-treated skin, you have a really strong decrease in the expression of those markers that can be restored when we treat them with some extracts. You also have aquaporin 3, which is a beautiful staining. Aquaporin are water channels that allows water to go through the layers of the skin, same thing. And we could also do some staining in the dermis with collagen, elastin that are also affected by this treatment and that can be protected using the plant extracts. So finally, what I wanted to show you is that we cannot just stop at the science when you do a product development, because you need to give this message to the marketing department, and they are not scientists. But you have people like Lorraine, she's my binôme, my teammate, let's say. She works an amazing job. She has basics in science, but she's not like a scientist per se. But she understands a little bit science, and she's going to valorize and get claims out of the science that we do. And she is the transition between us and the marketing. So from what I showed you, the impact of glyoxal on the skin, for example, she's going to say that you have less fibers, matter production, which is going to induce skin sagging, loss of volumes, or less skin cell cohesion, which is going to induce wrinkles, less hydration, less aquaporin, which is going to affect the color of your skin and gives this dullness to the skin. So this is just to show you a little bit the process between the science and the marketing, which is kind of in between. And these types of positions are really, really fun and really nice. And if you're creative and you know how to make nice slides, maybe that's something you could be interested in. And the final step is really 100% marketing. I'm going to show you. So it's not to advertise for Dior at all. It's just to show you the process. And also to show you that when you see a video like this, yes, it's beautiful and it's wow, how do they do that? But then you think there is no science behind that. But that's not true. In fact, there is tons of science and years of work to reach that. Again, for this product, 3 years, PhD with a very nice publication, plus 2 years of work on those bioprinted skin models. So it's not like you don't do science. And that's also a message I really wanted to give to all of you. Sometimes we think that in academia we do real science, and in industry a bit of science, but it's not real science. And I disagree with that. And even in cosmetics. So just think about that and don't have, comment on dit, prejudgment, thank you. So the final slide, I hope I'm on time. I'm showing you again my little note about the difference between academia and industry. So I already run you through all those, so the freedom for exploratory research, etc. I'm not going to do that again, but I wanted to add a few more, which to me are also extremely important. First, mentoring. I had the chance to work with amazing scientists every time during my PhD, my postdocs, even when I went to meetings, or even when you choose your PhD committee, for example, you and your PI, you choose your PhD committee. I had, for example, Joachim Lingner, who's at the EPFL in my committee, who's an amazing scientist, and he was kind of a mentor to me in some ways. We never really worked together, but meeting these people, talking to them at meetings, that really make you grow and really know what you want to do next. I think that's very important. Mentoring is super important. And it goes with networking, obviously. The scientific environment is super important. You have to feel comfortable where you're going to do your PhD, your postdocs. If you don't feel the connection with the PI, if you don't feel good in that environment, just don't go there. I'm coming back to the Salk Institute. I felt good there. And that's when I thought, okay, I'm ready to do my PhD there. That's important. It seems like it's not one of the top things to consider, but I think it is. Opportunities. Some people I know have all their career planned ahead of them. I wasn't like that, but I know some people are like that. It's okay, it's maybe probably a very good idea, but don't miss opportunities. I think you need to also look at what's out there, and maybe that's not what you plan, but you meet someone at a meeting, he offers you a position as a postdoc in his lab, her lab. Just consider it, not just because you decided you wanted to do this, just be open. And it goes with being adaptable and flexible. Don't be too strict with yourself. Just go with the flow to some extent. Don't plan too much. Have an open mind. And something very important, by choice, good choice, is what you make of it. I already mentioned this before. Sometimes we have a choice to make. It happened to me. I really didn't know what to choose. And it was a nightmare. I couldn't sleep. I was dazed. What should I do? You don't know what's coming. You don't know if you're going to be successful or not. It's horrible. I mean, you have to make a decision on something you don't even know. But I think it's important to consider, once you've done the decision, make it work, make it yours. And I think that's more important than just to think, did I make the right choice? Make it the right choice. Most important, enjoy doing science, whether it's in academia or industry. That's why I choose that title. Let's choose science and innovation. It doesn't mean much to say, oh, academia, industry. No, just do science and innovation and go with what you like. And the final word, experiment. Thank you very much for your attention.
Thank you for the great talk. I have a question from your transition between academia and industry. Was it your choice, proactive choice, that you look for industry, or did they come to you with this proposition?
They came to me. It wasn't my choice. Actually, it was kind of hard because, as I said, I had my own lab. So at CNRS, we have this great opportunity to put a hold on your job, like a sabbatical somehow. But yeah, they asked me. I knew people there because I worked there many years before. And I always had connections, networking, mentoring, every step of the way, keep contact. And they contacted me because they followed what I was working on, and they knew I was a good fit. And yeah.
Anybody else? Yes, over there. Could you pass the microphone along, please? There.
It's just I had a question because when working for the industry or working for a company, are the data and the results owned by the company? And if so, when publishing or when reporting the results, how much of influence or how much do they contribute to what is being reported? Like, are you free to report all the data and results, or does it have to be reviewed by the company or by the industry itself?
So it's a great question. So I'm going to talk for my company. Obviously, it might not be the same everywhere, but no, we're kind of free of doing what we think is the best. We are the experts, so they rely on us. The only thing I would say is that we do a lot of patent, and when you patent, that's the main thing we do. When you patent, you cannot publish. So you need to be smart what you publish, what you show at meetings. But we do a lot of publication as well. We present data at meetings. I'm going to a meeting. I have a podium presentation in October in Brazil. So it's just that people don't realize it because we do it as LVMH Recherche, and there is no real connection between that and the brands. But yes, but you're right. I think you're free, but it's just the patent thing that you need to be cautious about.
Mm. And one final question, lady with the white shirt.
Yep. Can you please?
Thank you for your presentation. I was wondering, how does the funding for research work in the industry, if you still have to apply for grants internally, or how does it work compared to academia?
Again, great question. I don't have to apply for grants, but I can, and we do. There are funding options with partnerships with academia and industry, so we can apply to that. But otherwise, the way it works, again, at LVMH Recherche, we work for the brands. So we have an idea. Let's say I want to work on inflammation, for example. I have a great idea. I want to collaborate with a specialized lab in the US, for example. I'm going to expose this research project to the CODIR, the comité de direction, the people in charge. And if I convince them that this matters, this is important, and that can lead to a product development, that's the main point. You always need to be convincing that this is going to be interesting, useful for product development, even if it's in 10 years. Mm. You need to see where this is going. Then they say, okay, they give you the green light, and then you get the funding. So we have kind of a global envelope, and then we do it like this. So you do have to run your ideas to some committee. They don't just let you do whatever you want, but we are quite free, which is very nice.